Is it visible?
Yes, sir.
Okay. So now definition of Laplace transform. Okay. So what is definition of Laplace transform?
Let f of t be the function of t defined for all positive value of t. Then the Laplace transform of f of t denoted by L, a function of t is defined by Laplace of function of t is equals to integral 0 to infinity e power minus st f of t dot dt.
Okay. So now I am writing what is that one? Okay, Laplace transform. Okay. What is that? The Laplace transform of a function. Okay, f of t. The function. What is the nature of the function? I will discuss later on. Okay, now. Okay, f of t. It will transform to L of s. Sorry, f of s. Okay, that notation is like that. So, and it is defined as L Laplace transform of f of t. Okay, equals to 0 to infinity, as your friends told. Okay, now e to the power minus st. Okay, s into t, f of t dt. Okay, that means you have to evaluate this right hand side integration to find a Laplace transform for the function given function f of t. Okay, here, okay, here s is what? S is, okay, s is a complex variable. Okay, complex variable. So you already know what is the complex variable. Complex variable means what will be the form? Now s will be like a plus I before. Okay, so and e to the power minus st. Okay, is called the kernel of the transformation. KER. Okay, this is the called kernel of the transformation. Okay, of the transformation. Kernel of the transformation. Of the transformation. Okay. What are the notation? Okay. Laplace transform, this notation, people are using different form of the notation. Okay, so these notations are like this one. Okay, some people L of this is standard. Okay, this is standard, but sometimes people are using like that f of s. Somebody are using f bar s. Okay, and you no need to worry about this notation. Okay, anything you can notation you can give like that. These are the general notations. Okay, we are using for the Laplace transform. So from this integration, okay, from this integration, what are the observations? Okay, what we can say from this transformation? Okay, we have to study first, then we will think about that the applications and so what are the observations? Okay, so what will be the observations for that? I will just discuss one by one. Okay. First one, say this one. Okay. So, like, what is d? Or we can say d by dt. What is this one?
Differentiation with respect to t, sir.
Yeah, correct. So this is what actually, if we say in that form, that d is an operator. Correct. So like that here, L is, so clear. So L is what now here in this case of Laplace transform is an operator. Okay, and which operates. So this one is okay, operates okay on a function. Correct. FUNC, that means function. Okay, on a function f of t. Clear. And then what it is happening? Then okay, like that here if we write d of f of x square, you can immediately write what? Twice
X.
x. Correct. So like that. Okay. Then f of t, what will be the Laplace transformation the operation? Then f of t operates, this one is, if it is operating on L f of t, then it is changes to f of s. Correct? Is it, and now this operation, so actually it is transforming f of s is a function, okay, function of complex variable. Complex variable. So we will study in details of the complex variable this semester itself. Okay, but you already know what is complex number or complex function. Okay, so regarding the complex functions, we will study this semester in details everything. But since you know a little bit concept on complex number, so it's enough right now. Okay. So what is this one? This is another one of observations. We have already studied this one. So now you see what is this? F of t is a function of t, and f of s is a function of s. Correct? And this term, but here it is different. Okay, now here variable remaining same on this operator. Okay, now. So here it is the changes, that is we can say in that form. Okay, that is okay. F of t, you can write all these things. Okay, now in t, okay, t is the domain. Okay, so t is the domain. Now if it is transformed to f of s, now what is the domain? In s domain. What is that? In s domain. Okay, what is that? That is complex, clearly. So usually, okay, what we actually we are studying that one. Okay, or usually we can say this one. Okay, usually we can say that is called time domain. T is time domain. Okay, time domain, and this one is frequency domain. Frequency domain. So this is actually the concept. Now, S is A plus. Why you actually were doing that one? You know, in case of differential equation, say this is D. So D square, you have studied this one, correct? D square plus 4D plus, okay, Y something, okay, equals to f of x, means x square. Say, how can you solve this differential equation when D is d by d, sorry, dy by dx, correct? So now this one is the differentiation of this function. And if you want to solve, okay, you actually have to solve this one using different technique. But in this case, that if you take the transformation of this type of differential equation, then from time domain to it will changes to frequency domain. That means it will change the differential equation. The differential equation it will change to algebraic equation. Okay, in terms of s, in term of s. So which one is easy to solve, differential equation or algebraic equation?
Algebraic, sir.
Correct. So that's the advantage of this one. So next, what are the next of observations? Observation 2. Okay. Now you have studied all these things in 12th standard. That one I am going to discuss. Okay. The Laplace transform already you know the is an integral transform. Okay, and it is okay is integral. What is that integration? 0 to infinity. Correct. It is an integral. Okay, integral. We can say that it is infinite domain. Correct. Why I am telling infinite domain? I have written. Now you should answer why it is infinite domain.
Upper limit is infinity, sir.
Upper limit is infinity. Very good. Okay, so that is the L of s. Sorry, f of s. Okay, representing okay that integration is in. So that means we can say that that is improper integration. Okay, you have studied this one. Improper integration you have studied or not? Improper integration. Yeah. So this integration actually always does not exist. Okay, you can't find the integration. So in that case, 0 to infinity. Okay, e to the power minus st. Definition: f of t dt. What is that definition of the Laplace transform? Okay, so due to this infinity, what you have to do? Limit. What you are writing? LIM or LT only? Limit. Limit. I am writing like LT, like that only. Limit. Okay, no? You can write LIM, no problem. LIM, limit. Okay, no? So it depends on you what you want to write. Okay, so next notes I will write LT limit. Okay. So this one integration 0 to t e to the power minus st. There is no relation between capital T and small t. Two notation only. Okay, t dt. So first, considering as definite proper integral, you evaluate it and then find the limit. In that way, you can divide. You can consider this integration. Okay. So in that case, okay, you can easily identify the limit exists or not. Sorry, the integration is exist or not, and then you can find the Laplace transformation of this one. So now the upper limit problem is solved. Okay, in that way. Correct. So you can easily find in that way the integration of the this improper integration. What about the lower limit? Okay, sometimes lower. So observation 3. Okay. Okay. So the lower limit. What is the lower limit? I go the
0.
0, sir.
So and you are finding the Laplace transform of f of t. So if I write 1 by t, find the integration. Find the Laplace transform f of t equals to. What is the problem? During integration at t equals to 0, the function a1 by t giving you the trouble. Correct? It's a problem for
Yes,
you.
sir.
So what you have to do for that case? Okay. So now the observation 3 is like that. The lower limit. Lower limit LL. Okay. Lower limit in the integration. Okay. Integration is 0. This is the main problem now in the case of observation 3. So the f of s, okay, this contains information on the behavior of what contains. Just check what I am writing. Okay, information. Okay, so what we have to do then? Where of f of t, okay, t greater than equals to 0. Correct. What about t less than equals to 0? What about t less than equals to 0? If I give you, find this one. Okay, sorry, f of t equals to t square. Okay, or even t lies between minus infinity to infinity. What you have to do then? So you can't apply. Okay, now so in that case, okay, if you apply, I will erase then. In that case, what you have to do? So that one only we are going to discuss now. So in that case, okay, what we have to do? We can apply one function that is we have, okay, one function that is Heaviside function. I am writing, you can define that one. Okay. Heaviside function. What is that? You can apply one Heaviside function. So what is that? H of t equals to 0 if t less than 0. T less than 0. Then 1 if t greater than equals to 0. If you multiply with this function, then the transformation of the function f of t, okay, f of t, the transformation of the function. What we have to, t is defined from minus infinity to infinity. Okay, so I have already told you t is defined. Okay, f of t is defined from minus infinity to infinity. Okay, then you can't apply directly that one for the Laplace transform. So what you can do, f of t, h of t. So f of t, whatever may be, if it is set square, correct. So if you multiply them, then it will be 0 if t less than 0 equals to t square if
F of
t greater than equals to 0. Correct. So this is the case. Just see, now I will replace f of t. Here it is f of t. So just now you apply this one Heaviside function. So for this case, no, I actually I discussed regarding 0. Now only next one. Sorry, next one. That is observation say 4. Okay, say 4. So at t equals to 0, correct. Now what is that one? At t equals to 0, if f of t has so many reason, it will be okay there. Okay, what will be the scenario then? Okay, what will be the scenario then? And then we can take. So can you guess what we have to do? So that means the function is not defined, or the function value is giving two value at 0. What we have to do?
will apply limits.
Apply
Limits.
limits. Okay, correct. So now say at 0 is the problem, but the function don't have any problem at this one. Correct. What I have written?
Yes, sir. 0 minus and 0 plus.
0
Neighborhood
plus.
of 0.
Yeah, correct. So this one is not too much. Your answer is correct only. Not here or not here. Correct. It's a, you can't imagine what how close it is. Okay, now. So
Yes, sir.
you know that neighborhood NBD. Okay. So then we can take. Okay. Then we can take, what is that one? Take the limit. Sorry, lower limit. Okay, 0 minus or 0 plus, and even and okay, 0 plus. That means what is our intention? Our
We'll
intention
take a
is,
value just after 0, sir.
so but no need to write any value. Okay, you write 0 minus or 0 plus. That means it is very close, and then find the integration. Then you just take it after the integration. If you are able to put the value of 0, it's put, you can easily apply that one. Okay. If it is not possible, then you have to consider the numerical concept only. That one we will discuss if we find such problems. Okay. So now already so many discussion. Now some, okay, mathematics, na? So we should do some work. Okay. Now, so now Laplace transform, pen and paper should be ready. Okay, now Laplace transform of some simple function. Okay, some function. So I will not write simple. Maybe that is not simple for all people. Okay, now. So simple function. Okay, now I'm writing one very simple problem first. Okay,